We are continuing to graph aggregate expenditures in Python. And so we're using this example here. We've done consumption and savings. We've looked at aggregate expenditures. So now let's look at investment spending, government spending, and taxes. So again, if you want to work along in this workbook, make sure I open the right thing here. Go to drstephpowers.github.io/econ in Python. Go to the aggregate expenditures link right here, and you will then go into GitHub, click on Google Colab. There should be a link right there. This will open then. Save it to your Google Drive by logging in and saving a copy. This allows you to edit the code and save it for yourself. Don't forget, if you are turning in assignments for my class in Python, make sure you save any changes that you do so that it's when you send me the link or when you submit the document, it is showing me your work. So don't forget to save there as you add and amend the code. Okay, so let's look at investment spending. Right off the bat, when we look at the data, we can see that investment spending, that's businesses spending, does not appear to change with national income. So let's plot investment spending. We are using matplotlib.pyplot as PLT. So if you did not graph with us in the previous videos, make sure you import matplotlib.pyplot as PLT. We are graphing against national income, so make sure you have entered in your national income. And we will be using linear regression here. So from sklearn.linearmodel, import linear regression and import numpy as np. So again, you'll need those. So make sure that you have imported those if you did not do the previous videos. All right, so as I scroll down, we are looking at investment spending. So let me just find the investment spending section. Now, in order to put in our investment spending, we do I equals whatever you want to call it. We've given it a name, and then we've simply copied the data from the table. So 75, 75, and I think that's about 9 times that it appears. So we input the investment spending data. We already have national income inputted into it because of our previous graphing. But if not, you need that line that says NI equals and then has the data for the national income. So we're going to do plt.plot, national income on the horizontal, investment spending on the vertical. We'll mark it with dots. X label is national income, Y label investment spending, and we'll add grid lines to make it easier to see what's going on. So notice, just as predicted, it's a horizontal line. It doesn't change with national income. So our formula for investment spending is just going to be I equals 75. It doesn't change with national income. But if you wanted to prove that to yourself, you're not quite confident to do that on your own, we can have our linear regression equation find us the formula. So we need national income to be reshaped for that linear regression function. And we need both of our data to be an array. So np.array is using that numpy package, puts in an array, and then in order for that linear regression model, we need to reshape whatever's on the x-axis. So we convert national income and investment spending to arrays. We call our model, which is linear regression. We fit it with national income goes first because it's on the x-axis, and investment spending on the vertical axis, so it goes second. Then we have it give us model.coefficient, model.intercept. Notice that coefficient is 0, that's the slope, and our intercept is 75. So our formula here is I equals 75 plus 0y if you wanted to have the whole thing, but really because you're multiplying times 0, this is just 75. Okay. So we look at that investment spending function, it's a horizontal line. The other thing we want to know is what would cause that horizontal line to shift up or shift down. Well, it's not going to be a change in national income because it doesn't depend on national income. So the question becomes, what gets businesses to be willing to spend more? So shift up. What gets businesses to spend less? Shift down. Now remember, investment spending is purchasing additional locations, right? Additional buildings. This is an expansion of the business, not just day-to-day operations. So what would cause that to change? Well, as mentioned in our previous videos, if there's a change in interest rates, for example, then businesses be more likely to buy more equipment, to expand if interest rates go down. If there's a change in the price of capital goods in terms of equipment, if equipment gets cheaper, then you're more likely to replace your equipment. If your equipment's getting old, so the age of your capital goods, then because you need that machinery in order to have your business function, you're going to have the business spend money to replace that equipment if it's getting older. We can also look at amount of spare capacity. So what's the ability to ramp up production? If there's no storage space, if all of our production lines are producing full time, there's no ability to ramp up production in the future, so we have limited or no spare capacity, then we would decide to increase our investment spending so that we can have that ability in the future. That's more warehouse space, that's more production lines, more capital goods. Business expectations. If you are optimistic about the future, the economy is going to start booming, demand is going to be high, then in anticipation of that, you want more spare capacity, you want newer, more efficient, better equipment, and so your investment spending goes up. The other thing to consider is government regulations. The more red tape, the more bureaucracy, that's going to limit your interest in terms of expanding your organization. So these can all shift investment spending. So if we go back to aggregate expenditures, total spending in our economy is C plus I plus G. So let's look at government spending. So again, we're going to follow the same process that we have with all the previous graphs. We're simply going to enter in here, we're going to enter in government spending. And just like investment spending, if we go back to the original table, you'll see government spending here, 160, 160, 160. We'll also pull the tax numbers so that we can graph government spending versus net taxes. And so we'll enter that in as well. So let me go back down. See if we can find where I put government spending here. So first we enter in government spending. We've actually already put in the taxes. So if I just go back up to where we did disposable income. So if you did the video where we found disposable income, you've already entered in the taxes. If you have not done that video, then make sure you hit play here and enter in the taxes. So now we have government spending entered in and we have taxes entered in. Now, let's go back. Now we can plot it. So again, we're using that matplot.lib and plt.plot, whatever's on the x-axis goes first, so national income versus government spending. And then we want to add to that same graph, national income versus net taxes. We have an X label of national income. We have a Y label, that's the vertical of government spending and net taxes. And because now we have two lines on this graph, we need a legend. So government spending came first in our code, so that was this first line. So we'll put government spending first in the legend. And then the second one we put in was the net taxes, so we'll put that second in our legend. The rest of the line of code for the legend simply says that the legend goes below, that's this negative 0.15. And because we have two labels here, we're going to have two columns. So they're side by side as opposed to one below each other. So let's run this. So here we have our graph. We have orange is net taxes. We have government spending, that's in the blue. The government spending you saw before didn't change. So we have this horizontal line here. But net taxes does. It changes with the amount of income. So you can see, for example, here at low income levels, the amount of net taxes is low, the government spending is high. So at these lower levels of income, government spending is more than tax revenue. We have deficit spending. We're spending more than we're bringing in. At higher levels of income, like up here, you'll see that the net taxes is higher than the government spending. So we have a government surplus. Okay, deficit spending, surplus. And here you can see this is where we balance the budget when the national income is $500. Okay. Now we can find formulas for taxes and for government spending. To do that, we use the same method we've been using in our previous videos, which is we need to convert our data into an array. Because we already converted national income into an array and reshaped it in the previous videos, we don't need to do it again. If you didn't run that before, make sure you do that. Otherwise, your linear regression will complain. So here we turn government spending into an array, and then we call our linear regression model. We're fitting national income on the horizontal and government spending on the vertical. Have it give us a coefficient. It's 0. That's what we predicted, right? Government spending doesn't change with income, so it's a horizontal line. The slope is 0. And the intercept we can call here is 160. So if we were to create the formula for government spending, it's 160 plus 0y, or just 160, right? And to find the formula for the net taxes, same thing, model equals linear regression dot fit, ni comma t. Now, we've already turned taxes into an array in our work that we did with our disposable income, so that's why I'm just going back here. So we did t equals array, and then the national income we had already converted over in the work we did previously, right? We reshaped the national income. And so that means that we can just call the linear regression model. Don't have to do any other conversions here. Run this, and then pull the coefficient and the intercept. You'll notice here we have a coefficient, we have a slope, and it's 0.2. So what that tells us is that as our income increases, for every additional $100 in national income, we are paying 20 bucks in net taxes, or for every dollar of national income, we're paying 20 cents. And we can also see here, before I leave the graph, that when income is 0, we're still paying some net taxes. And so our formula here is 60, that's the intercept, plus 0.2, that was the coefficient here, times y.